rectangles and squares you guys are probably familiar with from things that you've learned in the past. Just by a show of hands, you guys know what a rhombus is? I know what a rhombus is. Okay, good. At least one person, so that's good. So the good news is I'm going to go ahead and define it for you. A rhombus, and it's right here on the notes. In fact, would you do me a favor? Would you give everyone a... Here, I can do it. There's only 3 of you. A rhombus is simply a parallelogram with 4 congruent sides. A rhombus is a parallelogram with 4 congruent sides. So let me show you an example of something that's not a rhombus. Now, guys, I'm just drawing that freehand. Let's say that this is a parallelogram. So we know that, this side's parallel to this side, and this side's parallel to this side. This is not a rhombus. This is not a rhombus. That is a rhombus. A rhombus is a parallelogram with 4 congruent sides. Okay, what is a rectangle? A rectangle, that's what this is right here, is a parallelogram with 4 congruent angles. So this goes back to what, I think it was Jacob said this. Jacob, we did a problem on the warm-up, and Jacob said that all the angles are congruent. And here is an example of a parallelogram with 4 congruent angles. This is called a rectangle. Finally, we have a square. A square is a parallelogram with 4 congruent sides. And actually, this should be marked. All of these are exactly the same length. So fix your notes there. These are all the same. So we'll say that's 5, that's 5, that's 5, and that's 5. So you need all 4 congruent sides and 4 congruent angles. So it actually turns out that a square is both a rhombus and a rectangle. Because a rhombus has 4 congruent sides, well, so does a square. And a rectangle has 4 congruent angles, and so is that in a square. All right, so now we got to get, this is the, so let me write this up here. These are the definitions. And guys, you kind of need to know these definitions, okay? So on the quiz next week, I might ask you something like, a rhombus is a parallelogram with blank. And then you would have to pick what the properties are that make it a rhombus. Okay, so these are the definitions. In fact, let me highlight those. Let's go to the highlighter here. Oops. There we go. So the 3 terms that we're talking about today is rhombus, rectangle, and square. That's what we're talking about here. Rhombus, rectangle, square. Those are what we're talking about today. All right, let's go back to the clicker. Now, here are the key properties. Here's what you need to know. Okay, by the way, guys, just as a reminder, in Canvas, let me switch back to Canvas for just a second. In Canvas right here, this is week 1. Here's week 2. I already have a video posted on Canvas that I did about a month ago where I go through all the stuff I'm talking about right now. So if you've already watched that video, you already kind of know what I'm going to say. If you haven't watched that video, then you're kind of behind the 8 ball a little bit here. So you're kind of hearing it for the first time. So for a rhombus, here's what you need to know. The diagonals are perpendicular. So that's number 1. I'll call this number 1. If it's a rhombus, then the diagonals are perpendicular. So if we were to draw a picture of that, so let's say that this is oops, that's not a very good rhombus. That's a horrible rhombus. Actually, ooh, I just thought of something. There might be a rhombus in here already. Let's see if they've got a rhombus. I don't see a rhombus. Nope, not a really good idea. So I'm going to have to draw this one by hand, and that's okay. So let's make this a rhombus. So I need this side to be kind of the same length as that side, is the kind of the same length as this side. So there's my rhombus, okay? And just to make sure you know it's a rhombus, I'm going to mark those sides all congruent. So here's what this one's saying. It's telling us that the diagonals, that's what those blue lines are. Those are the diagonals. If that is a rhombus, those diagonals have to be perpendicular. Now, as you look at my picture, you can tell I didn't do it. That's not bad, but it's not perfect, okay? So that's number one. If it's a rhombus, the diagonals have to be perpendicular. Here's the second feature. The diagonals bisect the other angles. Now, let me explain what that one is. Let's do that one in green. So here's what I'm telling you. If this angle here measures 30 degrees, right there, this angle right here, guess what this angle has to measure? 30 degrees. If this angle is 30 degrees, then this angle is 30 degrees. Because what does bisect mean? Well, if we're talking about bisecting a segment, that means we're taking a segment and we're cutting it perfectly in half. So both angles are the same. If we're talking about angles being bisected, an angle bisector means it cuts the angle perfectly in half. In other words, both of those angles are going to be the same. So that's for a rhombus, okay? So that's for a rhombus. Now, let's look at a rectangle. So let me draw a rectangle over here. Actually, ooh, I can do that even better because I think I did see a rectangle up here, I think. Maybe. Let's see if this works. This might be just okay, that's just a square. That's not going to be good. Okay, I'm going to have to draw a rectangle, and that's okay. I can draw a rectangle. Those are pretty simple to draw. So here's my rectangle. The diagonals of a rectangle are congruent. In other words, this diagonal here and this diagonal here have to be the same measure. So let me go ahead and label that. So let's say that this is quadrilateral A, B, C, and D. If that is a rectangle, then we know that, and I'm going to write it right here, that AC, that's this segment, that diagonal, has to be congruent to this guy here, which is DB. So the diagonals are congruent. Now notice up here in this rhombus, is this diagonal the same length as that diagonal? I mean, you could just look at it and see this one's shorter than this one. So that's not true in a rhombus necessarily. But in a rectangle, this length has to be the same as that length. All right, and now let's talk about squares. The diagonals have to be perpendicular. You might say, wait a minute, Mr. Allen, we said that was about a rhombus. Well, guess what a square is? A rhombus. And since a square is a rhombus, then that means it has to have all the properties of a rhombus. The diagonals bisect a pair of opposite angles. Wait a minute, we just said that about a rhombus as well. Well, we just already established that a square is a rhombus. So all of the properties of a rhombus apply to the square. The diagonals have to be congruent. Well, guess what a square is? It's a rectangle. And since it's a rectangle, and the rectangles, the diagonals are congruent, therefore the diagonals of, in fact, this square is kind of this special quadrilateral. It's literally almost, it has all the wonderful properties that we would like to have. We know that opposite sides are parallel. We know that opposite angles are congruent. We know that opposite sides are congruent. We know that the diagonals are congruent. We know the diagonals bisect each other. We know the diagonals bisect opposite angles. It literally has all the things that we want. Okay, let's go ahead and start a few of these. So let's look at let's do one or two of these together, and then I'm going to have you guys work on your own, okay? So I'm kind of done with the presentation part of things, and now we're going to work on some practice problems. It says, decide whether the parallelogram is a rhombus, a rectangle or square. In fact, let me add a little bit to this. I'm going to put, it could be more than one. Oops, I'm not sure what I'm spelling there, but that's not more. It could be more than one. So let's look at example number 1. Now, most of you guys would look at this and you would say that it's a what? What would you intuitively say? Anthony, what would you say number 1 is? Just looking at it from your knowledge of stuff from the past.
Oh, looks like a square.
It looks like this one right here looks like a. Are you talking about number 1 or number 2?
Number 1.
Okay, so I don't think it looks like a square. I think number 2 looks like a square. Would you agree with that?
Yeah.
Okay, so we'll do number 2. So would you guys agree that number 2 is a square? Can anyone tell me what else number 2 is? So we've established it's a square. Is it anything else? Well, let me ask you this question. Is it a rectangle? Is this shape here, a number 2, is that a rectangle? Well, let me ask you this. If it's a square, and by the way, let's go back up to our definition of a square. A square is a parallelogram with 4 congruent sides and keyword, and 4 congruent angles. So that means that this angle is congruent to this angle, is congruent to that angle, is congruent to that angle, which makes it a rectangle. Is it anything else? So far, we've established it's a square and it's a rectangle. Is it a rhombus? Jacob's shaking his head yes, and he's right. And the reason that it's a rhombus is if we go up here and look at our definition of a rhombus, what's a rhombus? A rhombus is a parallelogram with 4 congruent sides. Do we have 4 congruent sides? Yep, so this is a rhombus. The question is, decide whether the parallelogram is a rhombus, a rectangle, or a square. Now, I claim on this problem, because Anthony said, let's do the square one, it's all 3 of those things. But what if I asked you what the best answer is? What do you think the best answer is? Is rhombus the best answer? Is rectangle the best answer? Or is square the best answer? You know what, guys? I think I might have just messed this one up a little bit. Does anybody see where I messed up? I think I've screwed this one up. You maybe noticed this, Mr. Stewart. Guys, I've made a mistake here, not on purpose. I would love it if someone could tell me what's wrong here. Mr. Allen just made an assumption. All right, well, let's go back to number 1. I claim there's something wrong here, guys. I'll let you figure out. There's a mistake. Mr. Allen made a big mistake here, and I'll come back to that if you guys can't figure out. Let's go back to number 1. Okay, let's look at number 1. What do we see here? We see a right angle, a right angle, a right angle, and a right angle. Would you guys agree that those are all right angles? If those are all right angles, that means that they're all congruent angles, correct? So is this a rectangle? Is that a rectangle? Let's go back up and look at our definition of a rectangle. A rectangle is a parallelogram with 4 congruent angles. Would you agree that we have 4 congruent angles here? Yes. Okay. Is this a rhombus? Is this a rhombus? Well, in order for it to be a rhombus, we have to have 4 congruent sides. Do we have 4 congruent sides here? The answer is right here and here. You see how there's only one mark here, but there's two marks here? That means that these two sides are congruent and that these two sides are congruent, but it does not mean that these two sides are congruent. So the only answer for number one is rectangle. Rectangle is the only answer that is correct here. Okay, so let's go over back here to number two. Did anybody figure out what Mr. Allen's mistake is on number two? This is like I'm teaching myself. All right, so let's go ahead and go to the other side then. Guys, there's a mistake here, okay? Mistake, major mistake. I'll come back to it later. I'm going to leave you guys to it though, okay? All right, let's look at number 9 here. Okay, I'm going to do one more of these and then I'm going to let you guys do some work on your own. Determine the measure of the numbered angles in each, and it tells you that it's a rhombus, okay? It says find the measure of the numbered angles in each rhombus. Now I'm going to come back here to this first page. Remember, a rhombus is a parallelogram with 4 congruent sides. In addition to that, we know that a rhombus has diagonals that are perpendicular, and it also has diagonals that bisect the opposite angles. So when we look at this particular problem here, we know that it's a rhombus, that's given, and since it's a rhombus, I know that the diagonals bisect opposite angles. And the reason I know that is, well, that's what I just told you right here. The diagonals bisect pairs of opposite angles. So, if this angle right here is 35 degrees, what would the measure of angle 1 be? Well, if this is 35 degrees, then angle 1 also has to be 35 degrees. Okay, so we got that angle. Now, this is where things get interesting. What will be the measure of angle 2? This is a harder question. How are we going to find the measure of angle 2? Well, let me explain to you how we're going to do that. First of all, this is a rhombus, and since it's a rhombus, it's also a parallelogram. It is also a parallelogram, which means that this side and this side have to be parallelogram or parallel. And let me make sure I get this straight here, guys. Remember, what is a rhombus? A parallelogram with 4 congruent sides. So I know that this side and this side has to be parallel. Now, if this angle is 35 and this angle is 35, together this whole angle is 70 degrees, right? So what would this angle have to be then? Does this angle here have to be 70 degrees? If these two sides are parallel? Would that make sense? That doesn't make sense. Because these two angles would have to be supplementary from what we've done in the past with what we call consecutive interior angles. So that means that this angle here has to be 180 minus 70, which is 110 degrees. This whole angle right here has to be 110 degrees. Because I need this angle and this angle to add up to 180. Okay, so
Mr. Allen, alternates. Why do they have to be supplementary?
because they're same side interior angles. Same side interior angles. Same side, or not same side interior. Same. Did I say that? So you guys remember when we did parallel lines and we had a transversal like this? We had alternate interior. We had same side interior. We had alternate exterior. I think this is, was that chapter 3? I don't know what chapter it was. I think it was chapter 3 or chapter 4. It doesn't matter which chapter it was. So for example, I'll call this angle, let's just keep it simple here. Let's say that this is angle 3 and angle 4. Angle 3 and 4 are what we call same side interior angles. And same side interior angles, when the lines are parallel, these two guys are what we call supplementary, which means they add up to 180. Anyway, so these two guys are going to have to be supplementary. So this is 110. So if this is 110, then the measure of angle 2 is going to have to be 55 degrees. It has to be half of that. So in fact, let me erase now all this stuff I've got here. So since this rhombus is a parallelogram, then the diagonals bisect opposite angles. If this angle is 35, then this angle has to be 35. So that's the easy part. Number 1, angle 1 is 35. That's easy. The harder part is figuring out what that angle is. And since this side is parallel to this side, if this is 70, then this angle over here has to be 110, because 70 plus 110 is 180. That's what supplementary means. And then I got to take that 110 divided by 2, and that gives me 55. Okay, that is, okay, we have about 15 minutes left of direct instruction, so I'm going to stop there. And I am going to go ahead and have you guys complete some of these other problems. Oh, I guess I should go back before I do that. Did anyone figure out the mistake here? Did anyone figure out the mistake on number 2? I didn't do it on purpose. It was an honest mistake. Okay, so, do that one if you want, do 3 if you want, do 4 if you want, and then do, so let's see here, in any of these problems here. And I'm going to come around and help the students that are here in class. Those of you guys that are working virtually, you just got to go and work on your own. Mr. Stewart will be there. I'm not going to put you in breakout rooms. I'm going to let you just kind of work at your own pace, okay? There is some important announcements I need to make at the end of the period, though, so please make sure you don't log off. I'm going to go back to this one right here. Okay. And I'm going to stop recording.